Hello everyone, welcome back. Today we'll be discussing 5.3, Riemann sums and definite integrals, and after today what you should be able to do is understand the definition of the sum, evaluate definite integrals using limits, and evaluate definite integrals using properties of definite integrals. Alright, so let's begin. Now before we start, last lesson we went over some summation formulas and I explained this stuff to you. We're going to be using the expanded form. So the summation, four basic summation formulas: sum of I, constant times upper limit term, sum of, the sum of C. Sum of I is n plus 1 over 2, but if you expand that, n squared plus n over 2, okay, it's a lot easier using this form. This one, what you do is you double form, pretty much like a double FOIL. So you got n squared plus n times 2n plus 1. Gives you 2n cubed plus 3n squared plus n over 6. All right, and then here, what you're going to do is you're going to FOIL that and then distribute the n squared in, and you get the sum of I cubed, n to the fourth plus 2n cubed plus n squared, all divided by 4. All right, so those are the four basic summation formulas that we'll be using. Okay, so the expanded form makes it a little bit easier, saves up this step. All right, so anytime you see one of these, I'm just going to jump right into these formulas, so I don't have to expand it for you. So, Riemann sums, partition with subintervals of unequal width. So this means, as you can see here, the intervals are not all the same width. And the ones that we did before, with the maximum minimums, everyone had the same delta x. Delta x was the same. Now in this case, delta x is I, okay? So that means they're different widths, okay? So as you can see, this one's skinnier than this one. It gets a little bit larger as you go, and depending on what we do, it changes, okay? Now in this case, okay, in these cases, you have f of ci equals delta xi. Now ci changes, okay? That is the right endpoint of each one of these rectangles, okay? So in this case, it's 1 over n squared. In this case, it's 2 squared over n squared, n minus 1 squared over n squared. So as you can see, based on this right here, them changing, it is whatever the top number is squared over n squared. So it's just I squared over n squared. All right? Now, delta xi, this piece right here, is the width of the ith interval. So whatever interval you're on, for instance, 1, 2, 3, 4, dot, dot, dot. So 1, 2, 3, 4, 5, it would just be ith interval, so 1 squared, 2 squared, 3 squared, 4 squared, that's where we got these, over n squared, okay? So that's how you end up finding the widths, right? So what we're going to do is we're going to expand this, solve this, and then later on we're going to be able to do it all together. All right, so the first one, it says consider the region bound by the graph. This is the square root of x function, and you're just going from 0 to 1, right? And you're going to evaluate the limit. So I want to know pretty much what about the area under this curve is. Delta x I, right? Subinterval I is whatever your right endpoint is minus your left. So it'd be like 1, this minus this, this minus this, this minus this, this minus this. So you subtract the two x points. Now the way you do that is you're going to take your CI, okay? Okay, because that's your right endpoint, and you're going to subtract right endpoint, the endpoint right to the left of it. So this is the right, this is the one that's right before the right. That's your left endpoint, okay? So if this was CI, this would be CI minus 1. If this was CI, this would be CI minus 1. If this was CI, this would be CI minus 1, okay? So it's right minus left, right minus left, right minus left. All right? Got it? A little tricky, but you'll get the hang of it. Now in this case, it is I squared minus n squared, as you said before, because that's CI. Now CI minus 1 is, you're just going to put I minus 1 instead of I. So it's I minus 1 squared over n squared. Now what you have to do here is you have to expand this. So you FOIL this. This becomes I squared minus I plus 1. So I squared minus 2I plus 1. And then you combine like terms. Since they're both over the same denominator, I squared minus I squared is 0. So you're left with negative, and a negative becomes a positive 2I. Negative and a positive 1 becomes a negative 1. And that's what your delta xi is. Okay? So you just plug in, use your CI to find this, okay? Because the reason for this is it keeps on changing. Depending on what I is, this width changes. It's not a constant width. Right? Hopefully I explained it enough. Try to take it long enough. Now, next step, the function. You type ci into the function. We said ci is I squared over n squared. So it's the function is square root of x, so it's the square root of I squared over n squared times delta xi, which is what we just spent all that time finding. Now you have to expand again. But before you do that, you have to square root the square root of I squared over n squared. You have to square the numerator and denominator. Take the square root of the numerator and denominator. The square root of I squared is I, square root of n squared is n. So it's just I over n times 2I minus 1 over n squared. Now when you multiply fractions, you multiply across. So you multiply I, distribute it in there, and the n here. So this would be 2I squared minus I, n squared times n would be n cubed. All right? Now you know what to do? Now we have to go back into our summation formulas I just showed you before. What can we pull out of here? As we did last lesson with the minimum maximum, it's the same way to solve this now. We could pull out the n cubed. All right? So, also you could split this up. It doesn't matter which way you do it. So the way I did it, I guess, here is I did 2I squared divided by n cubed minus I divided by n cubed. And then I just pulled out the 2, the n cubed, and then I pulled out the I and the n cubed. That's why this stuff's out here, because we just want our summations. And remember, just go back to the previous slide. We said I squared is this, I is this. I'm not going to explain it, I've read that every time. But this is just from the previous one, the expanded summation formula. And this piece right here just gets replaced with this, and this right here gets replaced like this. All right, so you're left with the 2 over n cubed out front, and here you're left with negative 1 over n cubed out front. I didn't have enough space to keep on expanding and expanding. That's why it's like that. All right, so final step, you have to distribute the stuff in. So you distribute the 2 on the top, distribute the n cubed on bottom, minus 1 on top, n cubed on bottom. Or you could just leave the negative out front and just leave the top the same, the numerator the same, and just distribute the n cubed on bottom. All right. Now, the key to this is the limit as n approaches infinity, okay? So using L'Hopital's rule, all right, unless if you end up with a greater exponent on top, all right, degree, your answer is infinity. That would destroy your answer. If you end up with a greater one on bottom, your answer goes to 0. If they are the same, they both are raised to the same power, it becomes a constant, and that's what we want. So in this case, when we cancel this out, we're going to divide everything by 6n cubed. In this case, we divide everything by 2n cubed. So these right here, if I expand it, 4 over 6 reduces to 2/3, and the n cubes cancel out. 6n squared over n cubed becomes 1 over n. 2 divided by 6n cubed becomes 1 over n cubed. And then you got minus n cubed over 2n. So this becomes the 2n cubes cancel out, leaving you just a 2n on bottom. And then n over 2n cubed becomes 1 over 2n squared. Okay? Now when I type infinity into this, this stays, right? Because there's no constant. 1 over infinity is 0. 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 0, 0, 0, 0. So our answer just ends up being 2/3. That's why you use this rule, because it cancels out everything and just leaves you with the constant. And that's really it. Not too difficult. Not too terrible for the first shot, right? Why don't we try another example? All right, so in this case, as I said before, delta xi is your right minus left, or it is your ci minus your ci minus 1, okay? Now in this case, I'm just going to tell you ci is 3i squared over n squared, and here's the limit formula we've been using. So first thing I want you guys to do is use ci to find delta xi. So go. All right, let's see. So you got 3i squared over n squared minus, you're going to put I minus 1 there. 3 times I minus 1 squared over n cubed squared. I minus 1 squared, once again, is I squared minus 2i plus 1. Take the 3, you have to distribute the 3 in. 3, negative 6 and 3. And then because these have the same denominator, you subtract like terms. Cancels out, leaving with negative 6i plus, minus 3 over n squared. Sorry, positive. Negative. Negative is a positive. Negative and a positive is a negative. Okay. When you have a negative out front, you have to distribute it to everything in the numerator. All right? All right. So we got a delta xi. F, which is square root, so we're going to do the square root of that stuff, times delta xi, which is here. Square root of this, square root of the top, well, square root of 3 is just a regular number. I think it's around like 1.7, so we can just leave it as square root of 3. Square root of I squared is I. Square root of n squared is n. Okay, so you got square root of 3, which is a decimal, and then I and n. All right, and then you end up with 6i minus 3 over n squared. The reason I left this as square root of 3 is it's more accurate if you leave it like that to the end. Distribute 6 square root of 3, I squared minus 3 square root of 3 and an I, right? N cubed. Got it? All right, let's see. Nope, can't combine these because one's an I squared, one's an I. So what we're going to do is we're going to pull everything out. We're going to divide this by n cubed and this by n cubed. All right, this by n cubed minus this by n cubed. So I split it up, and now I could pull out everything that's not an I out front. So in this case, I can pull the 6 square root 3 over n cubed out front, 3 square root 3 over n cubed, pull it out front. Leave me with my I squared and my I. The reason I do that is so I can use my expanded summation formulas, which happen to be from the first slide, right there. This goes in for the I squared. This goes in for the I. See, it's not really that bad. Now, can you kind of cheat here and say, okay, I know this is an n cubed, so I'm only going to use this one. I don't care about this stuff. Of course you can. Can I say this is an n cubed? None of this is ever going to work. I know that for a fact this is going to become 0. Of course you can. That's what I'm doing, but I'm just showing you the expanded form just to help you guys out, okay? So next, 12 radical 3, n cubed, 18 radical 3, where's 6 at? No, I forgot my 6. And then radical 3, okay? Or you can just do 6 divided by 6 is 0. So instead of putting all these over 6, I just cancel these 6's out. And just made this 2 radical 3 n cubed plus 3 radical 3 n cubed plus radical 3 over n cubed, because once again these 6's cancel out and make them 1's. Obviously doesn't cancel out, so that's why you got the 3 radical 3 n squared minus 3 radical 3 n over 2 n cubed. Divide everything here by n cubed, cancels out, leaving me 2 radical 3. You're going to end with the, where is it at? 3 radical 3 over n, radical 3 over n squared, and then with this, you're left with 1 n on bottom, and you're left with 2 n's on bottom. Anytime you have an n on bottom, as long as your limit is approaching infinity or negative infinity, if it was a number, you'd actually get an answer. Because it's approaching infinity, meaning there's an infinite number, okay? What we got? Anything? The outcome becomes 0. The answer is 2 radical 3. That's it. Once you get to the end, it's easy. Got it? And this summation just means pretty much there's an infinite number. You go all the way up to the infinity. 1, 2, 3, 4, 5, 6, 7. Right? We good? We good? We good? We good? All right. Let's move to the next problem. Why don't you guys attempt this one? And then I'm going to tell you how to actually find the CIs. All right. Another hint. I cubed over n cubed. Like I said, I want to just warm you up with the stuff. CI minus 1, I cubed, n cubed, I minus 1 cubed, n cubed. When you expand this, it's I minus 1 times I minus 1 times I minus 1. Or you can plug it into the equation. What's it? A minus 3ab, 3 minus 3ab squared minus 3a squared b, what is it, minus b cubed, something like that. All right, over here, this expands to this, I cubed minus I cubed equals 0. And now you're left with 3I squared minus 3I plus 1 over n cubed equals delta x. So now we have 3 terms. Doesn't matter. This goes to that equation. This is your delta xi. Alright, that's what this is here to show you. The cubed root of a cubed thing just becomes I over n. You distribute the I, distribute the n, so you get 3I cubed, 3I squared, I over n to the 4th. Now you're going to divide each one of these by n to the 4th. Alright? And then you're going to pull out the constant, and you're going to pull out the n4th. Pull it all out to the front. I cubed, I squared, I. So now you have 3. So now we need the I cubed one, which you haven't used in a while, n to the 4th plus 2n cubed plus n squared over 4. The I squared one, and the I. This replaces this replaces that, and this replaces you. Right? Very simple. Use these to plug into that. Distribute. Okay, if you can cancel, you cancel. 3 obviously doesn't cancel with 4, but 3 over 6 becomes 1/2. So you can do that. Oh, I didn't do it there. 3, okay. 4 to the 4th. 3 times 2 is 6. 9, 3. 6n to the 4th. N squared n, 2n to the 4th. Alright, so now we cancel. 3/4. Negative 3 over 4n squared. 1 over n. You got n's on the bottom. And what happens is we approach infinity when you got n's on the bottom. They go to 0. So it's 3/4 minus 0 minus 0, 0, 0, 0, 0. Alright. And your answer is 3/4. See that? It doesn't always come out that nice. A lot of times it does, but not always. Alright? Alright. So that is Riemann Sum. Now, who exactly is this man? Well, he was alive for 40 years in the 1800s. He's a German mathematician. He worked in the areas of non-Euclidean geometry. Sorry, my pronunciation is not very good this morning. Differential equations and number theory, okay? So he created this whole summation thing. So when you get very upset and can't get it, it wasn't me. I just teach it. Blame poor Bernard over here. But actually don't blame him, because without this, a lot of the stuff we do now would not be possible. This opens up the world of physics immensely. All right, very, very important. And you'll see that if you go to college to be an engineer, you use this formula. All right, so definition of a Riemann sum. Let f be defined on the closed interval AB, and let delta be a partition of the interval AB given by. And this is what it means. A equals XO, which is your original x value, which is less than x1, which is less than x2, you get the hint, which is less than x minus 1, okay, so this is the second highest term, dot, 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 all the way to xn. All right, actually my dot, dot, dot should have been here. All right, equals b. So that means that a is your smallest term, b is your largest, and then you have all these terms in between. Now the delta xi is the width of the ith subinterval. Okay, so now you're kind of cheating a little bit. You're just taking the interval of each subinterval. So ci at any point is the ith subinterval of x subinterval I minus 1, x subinterval I, and the sum, same formula we just used, but now ci is going to be between I minus 1 and xi. So we're just taking a value between the two intervals. That's called your Riemann sum of f for the partition of delta. So in this case, delta x is going to be simplified to b minus a over n. So now we're just giving it a constant width. Before, we said the widths were not the same. Okay, that was with different delta x's. In this case, all the widths are going to be the same, and they're all going to be so small, so it doesn't really matter. B minus a over delta x equals your n. All right, I'm sorry, over delta. Got it? This stuff always confused me. But when you see an example, you'll see how much easier it becomes. So what we're going to deal with today is definite integrals. Notice it doesn't say x is approaching infinity. It says your delta is approaching 0. So that is your limit. So now we're going to be focusing on limits as opposed to, we're going to go from Riemann sums to integrals, and we're kind of like go through. So here's how it works. F is defined on the closed interval, a, b, and the limit of the Riemann sums or the partition delta. So we just already discussed this formula. Now what it says is it exists. So F is said to be integrable. That means you can integrate it on a, b, and the limit is denoted by this equation right here, which is the same as the integral from a to b of f of x dx. So now you have a lower limit and a higher limit, which we did before. So now we're going to get into actually using our integrals again. The limit, this is a lot easier, is called the definite integral, okay, hence definite integral, name of the lesson, of f from a to b. The number a is the lower limit of integration, and b is the upper limit of integration. So that's pretty much your lowest x point, your highest x point, okay? That's your interval, a, b. Your start point, your end point. All right, so what this means, continuity implies integrability. A lot of weird sounding words today. All right, so if the function f is continuous on the closed interval a, b, then f is integrable on a, b. That is, very simply, the limit exists. The integral exists. So before when we're saying, what it means is if it's continuous and it's a closed interval, meaning closed circles at a and b, and no asymptotes or holes in your function as it goes from a to b, it's just one solid line, you're good, all right? And when I say it's a function, it means it can't like zigzag back and forth. That'd be cheating. That wouldn't be a function at all, right? All right. Now for 4 through 11, we're going to evaluate the definite integral. And this is pretty much the core of today's lesson. All right. Before, Riemann sums was a little warm-up. This is a core. Right? Now we're not given our little hint of CI, so we have to find CI ourselves. So I made 3 simple steps, and we're going to use these steps to solve each one of these problems. And by the end of this, you guys will be excellent. I put a little graph here just to help you guys see what we're actually doing. So when it says the definite integral is going from -2 to 1, it means my start point is -2, my end point is 1. So we want to find the area under the curve. So that means pretty much the area from the curve to the x-axis. Okay, so if you're on the negative side, you're finding it here. If you're on the positive side, you go under. So sometimes you're over the curve, sometimes you're under. Delta xi, we said before, is b minus a. So first thing you do is your b is your big number, small number. Okay, b is always going to be larger than a. All right, so your answer here is 1 minus -2. B is your end point, start point. So 1 minus -2 is 3 over n. All right, now, another thing. This, being that b is always larger than a, will always be positive. If your answer is negative, it means you went backwards. Go again. All right, so top minus bottom. Got it? So far, so good. Let's look at 2. Choosing CI as the right endpoint of each subinterval produces the following. So now CI is your start point plus the width of delta x is your width, right? Times I, what interval you're on. So all you're going to do is to find CI each time is do the same thing. So first, ready? I'm going to point and you yell it out. What's A? Did you say A is this thing, which is this thing, which is -2? All right, when's it -2? It's always -2. So now you got I times delta x, and what do we find delta x to be? 3 over n. So CI right here is -2 plus 3i over n. Okay, so step 1 is to find delta x. Step 2, we're going to use delta x, and we're going to use our lowest x value to find CI. Okay, you remember CI is the right endpoint. CI, 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 CI. So there's a bunch of CIs. All right, so now we're going to use the definite integral formula, which is right here. All right, definite integral formula. Instead of using delta is approaching 0, we can use the Riemann sum over here. All right, and I don't know if it's Riemann or Riemann. Different people call it different things. So I'm going to call it post. That way I don't mess up half the time. All right, so from there, so when I do this formula, right here, right? F of CI. So F, my function is 2x. I'm going to take my x, and for my x, I plug in my CI. So F of CI would be 2 times negative 2x, no, negative 2 plus 3i over n. So my function, 2 times x, right, times delta xi, which is the same as delta x, which is 3 over n. All right? You follow me so far? Not terrible. See, we got all those problems to figure this out too if you can't get it. Now, you expand. Distribute the 2 in. All right? Or distribute this in 2. And what we're also going to be doing is we're going to be pulling everything out. So there's 2 ways you could do this. One way is to make this negative 4 plus 6i over n and then multiply this and then make that with negative 12 over n plus 2 times 9, 18i over n squared, and then pull them out. I find it easier to pull out anything that comes first. So if I take my 3n and take my constant, multiply them together, 2 times 3 is 6 over n, and I pull that out, I can put that in the end. Okay, if you want to put everything together first, that's fine. I'm going to show you both ways to do it. It's all pretty much preference. And then you got your negative 2 plus 3i over n. Now, my 6 over n stays out front, okay, and that's the key. You got to keep it out front to the end. Negative 2, so I'm going to summate both these. So this is a sum of negative 2, and the sum of, I could take out my 3 over n and keep my I. So here's my summations, constant and my I. Now, in this case, I don't go with the space to show you. The constant is c times n, so it's negative 2 times n, and then the summation of I is n squared plus n over 2. So you're actually just putting this expanded form right in for your I squared, your I cubed, okay? This one you just do whatever this is times n. Got it? And the 6 over n stays up front. So now what you can do is you can distribute the 3 in, distribute the n in. So you got 6 over n times, this stays the same. 3n squared plus 3 over 2n. Now, distribute the 6n to both of these. So I just do it in the end. In the beginning, doesn't matter. 6 times negative 2 is 12, and keep your negative, over n. And watch what happens here. 6 times 3n squared is 18n squared, plus 18, and then 2n squared. Reduce. N's cancel out, leaving you with negative 12. All right, n's cancel out, leaving you with the 9. And then 18n over n cubed, as you approach 0, is 9 over infinity, which is 0. Okay, as we approach infinity, sorry. Negative 12 plus 9 is negative 3. All right, remember, if more variables on the bottom, as you approach 0, cancels out. This is the same. This says the same, so that's why you got negative 12 plus 18. And 18 divided by 2 is 9. And there's your answer, negative 3. Hopefully I did a good job explaining that. What do you think? All right, let's go to the next one. Ready? You're going to try these on your own. So, back is going on me. First step, find delta x. 4 minus 0 over n. That wasn't too tough, was it? All right, second up, CI. All right, so let's find CI. How do you think you find CI? A, I times delta x. So you still good? A is 0. I, delta x is 4 over n. So it's just 4i over n. All right, so that is your CI. You good? Delta x, use to find CI. Plug that in for both x's. Plug that in for that. So it's 4 times 4i over n minus 4 over n squared times 4 over n. Now, 4 times 4 is 16 over I over n, 16i over n. 16i squared over n squared times 4 over n. You remember what I do with this 4 over n? I'm going to pull that forward. Okay, that was the way I did it. Remember I said I'm going to show you both ways? So you could pull this forward. You could even pull the 16s with it. And you can even pull the ends with it and wait to the end. Or the second way, once again, your preference, showing you both ways. Take the 4, multiply it by both things here, and you can distribute now. So pretty much you can distribute now, you can distribute later. 100% up to you. I do it both ways to show you which way maybe you're comfortable with one more than the other. So 4 distributed both of these, 64, 64, n cubed and n squared. They multiply both of these by n. And now when I do this, what I do is I'm going to pull out the constants and pull out the n's. Pull them out first. I'm left with an I here. Pull this and this out. I'm left with my I squared. Then use my expanded summation formulas. Just replace this I with this. Replace this I squared with that, as we did with the first couple problems. And now you just have to distribute in. 64 gets distributed in, and squared gets distributed, and the same thing here. All right? Now, what you do next is you reduce 64 and squared, so you can divide both of these by this number, all 3 of these by this number, and you don't have to expand it like this. This is just to show you in case you didn't get it before. Just I had more space here, so it's a little bit easier. And then reduce all these. You're left with 32 plus 32 over n, 64 over 3, right? Now all these n's, because I'm approaching infinity, become what? 0. So you're left with 32, 0, 64 over 3, 0, 0. 32 minus 64 over 3 is like 34 minus 21.3, which is 32 over 3, or about 10.7, 10.6 repeated. All right. Better? Usually by problem 6 is when we start getting decent, I would say. So when you go to 10th problem number 6 and 7. These are a little easier. All right, this problem, delta xi, 6 minus 2 over n, which is 4 over n. So to find ci, we're going to use our a, which is 2. 2 plus 4i over n. All right, remember, numerator, numerator. Good. All right, we're going to type it into our formula. Now, because there's no x here, there's nothing to type ci into. See that? A times 4 is 32 over n. Now watch what happens here. What's our answer? 32. Why? Because 32 over n times, we're going to pull out a 1 over n. Sorry, I jumped ahead. So, and then the sum of 32 is 32n, right? Because the summation of a constant is the constant times n. So it's 1 over n times 32 over n, which is the limit of 32. Because there's nothing to plug the x into, or the n into, your answer is 32. Got it? That's pretty easy. You want to prove this? I always like to prove these sometimes by just showing you the graph. If I was going to graph 8, that's the graph of 8, right? It's just a horizontal line where y, or f of x, always equals 8. If I'm going from 2 to 6, right? I want to know pretty much the area of that little thing right there, that light blue section. So if I was going to do this, let's say, which is geometry, this is a rectangle, right? If I did length times width, height's 8, width 4, right? Length times width, 4 times 8, right? 4 times 8 is 32. See that? 32, 32. So you can always check your answers if you want to, if you know how to graph the thing, and it gives you a geometrical shape that you can find the area for. Now, if it's a geometric shape that doesn't have a standard area, you can also always use this to find the area of that geometric shape. So look at this now, you can find this. That's why it's finding areas. Got it? All right, move on to number 7. Hopefully that didn't mess you up. All right, so b minus a, 3 minus negative 2 is 5 over n. Ci is a, which is negative 2, plus I, 5 over n, negative 2 plus 5i over n. Now, when we plug it into our equation, right, we have x. So we just plug this in for x, and then we have times delta x. All right, f of c, the function is x, so it just goes right in there. What do we do with that 5n? What do you want to do? I distribute it sometimes. Negative 5 times negative 5 times negative 2 is negative 10 over n. 25i squared over n squared. Pull those apart. All right, I'm going to pull out the n. I'm going to pull out the 25 over n squared. I just did 2 steps on one there. All right, so what I did was I just separated these, made them both sums, some of this, some of that, and then I pulled out. I left, the reason I leave this negative 10 in here is because this, it says it's a constant. I need to take that constant and multiply it by n anyway. If you want, you can pull this out and just make this a 1 and turn this into a n. Once again, preference. 25 over n squared, good. We use our formula, we know delta I is this. So use this here, negative 10n times 1 over n. 25 over n squared times this. Distribute the 25, distribute the n squared. Negative 10n over n. Cancels, giving you negative 10. 25 over 2. 25 over 2n. Becomes a 0. Right? Yeah. 2.5. Or 5 halves. You good? Gave you 2 easy ones. Ready to do another? Take it up a level? Of course I will. Alright, try problem 8. You know this one's harder because it's only one screen instead of split. Alright. So, start with delta x, negative 1 minus, subtracted from 1. 1 plus 1 is 2 over n. Negative 1 plus I times 2 over n is negative 1 plus 2i over n. Alright? Let's go. Let's use our little formula right here. We're plugging that in. You're going to cube this guy. Negative 1 plus 2i over n cubed plus, times this. Cube. So you're going to FOIL it twice, pretty much, or use the cube formula. So what happens here is, if you're going to cube this, all right, I did this in the other class because I had less space. You're multiplying it by itself 3 times, and then you multiply it by 2n. All right? So, much I could cheat here. I could FOIL this, and you don't have to do this. You're going to multiply all 3 together either. And then you got like a super FOIL there. It's not really a FOIL because it's not 2 sets of 2. It's a 3 and a 2, so it's like a super distribution. So you multiply these 2, you get this. All right? So pretty much the expanded form of this is this. You can get to it any way you want. I multiply these 2 by each other, these 2 by each other, and then multiply the 2 multiplies by each other. Like I said before, whatever you want to do. A lot of people go 1, 2, 3, and then 4. That's fine as well. I have 4 summations, right? Pull out a negative 1 over n, pull out a 12 over n squared, a negative 24 over n cubed, a 16 over n to the 4th. Because you want to keep your constant, I squared, I cubed. Now, this is going to be the hardest one. Here's your summation formulas, once again, from the first slide we did. So you're going to replace, this becomes just 2 times n, replace this with that, replace this with that, and replace this with that. All algebra. It's just algebra. As I told you, the first week of school, calculus is algebra. If you can do algebra and just expand on it, do it a little better, you can do calculus. Distribute. All right. After you distribute it, cancel stuff out. All right. Anything, since n is approaching infinity, with an n in the denominator now, becomes 0. So you're left with negative 2 plus 6 minus 8 plus 4. Number sense. Answer 0. All that works for 0. Now, why do you think the answer to this is 0? Anyone? Well, because you're going from negative 1 to 1, x cubed is a symmetrical curve. I don't know if you guys remember that. That's an odd function. It's actually symmetrical around the origin. It's the one that looks like the S curve, okay? So since you're going from negative 1 to 1, on both sides, from negative 1, when it goes up, the area above that is the same as the area above it. So when you subtract the 2 areas, you got all the positive in the bottom, they cancel each other out. It'd be a little bit better if I had a picture to show you, but I don't. All right. Why don't you guys try problem number 9? All right. So, problem number 9. Now, just so you guys know, what I was talking about before, this is a very crude drawing right here, but with the x cubed curve, I don't even know if you can see this. This is the area from -1 to 0. That area is all in the negative. The area from 0 to 1 is all in the positive. These two sections are equal to each other. So when you add the two areas together, they actually equal 0. All right, so sometimes that happens when you go from a negative to a positive. All right, so you don't always, the area in the curve can be a 0. Hopefully you saw that. I don't know. Anyway, let's continue on with this lesson. This number 4 minus 1 is 3 over n. The CI, we got 1 plus 3i over n. Oops, jumped the gun. Plug that in, you're going to square that and then multiply it by 4. So 1 times 3i over n, so this becomes 1 plus 3i over n times 1 plus 3i over n, which is 1 plus 6i over n, plus the squared is 3i is 9i squared over n squared, and then 4 times 3 over n is 12 over n. All right, distribute this in here, and you get 12 over n, 72i over n squared, 108i squared over n cubed. All right, now I'm going to split this up. I'm going to pull out a 1 over n, pull out a 72 over n squared, and a 108 over n cubed. All right, you can do it in 2 steps if you want. 1 step is fine as well. Use my formulas. 12 times n. I becomes this. I squared becomes that. All right. 12n over n. 72n squared plus 72n over 2n squared. 216, 324, 108, and that becomes 6n cubed. When you cancel, left with the 12, left with a 36, 0, 36, this is going to become 0 and 0. 72 plus 12 is 84. See that? Not too terrible, right? All right, why don't you guys try number 10? All right. And if you guys want, you can always go on Desmos, type in these equations so you see what the graph looks like. And then see, actually, look under the graph and see, okay, that looks about 84. You draw like a little shape, like a little triangle or something like that, or I'll show you later on. And just to check your answer so you can see actually what's going on here. Obviously, I only have one TV, so I can't do that as I could do in the classroom, as we did in the classroom. Delta x, 2 minus 1, is 1 over n. 1 plus I times 1 over n, 1 plus I over n. 1 plus I over n squared plus 1 times 1 over n. Foil that. You get 1 plus 2i plus n plus I squared over n squared plus 1 times 1 over n. Now you don't want to distribute this in yet because of what you could do. 1 plus 1 is 2. So you got 2 plus 2 over I, 2i over n, plus I squared over n 1 plus times 1 over n. Too many n's sometimes. Distribute that in, okay, and then you can do the sum. All right, you still doing good? Pull out your stuff. So I pull out a 1 over n, 2 over n squared, 1 over n cubed. Use my formulas. 2 times n, I squared once again becomes this. I becomes that. I squared becomes this. Do you have to distribute it to all, even though I know this is going to become a 0? No, I usually just circle the biggest terms and use them. All right, I kind of cheat. But I'm just showing you how stuff goes away. 2n over n, 2, top stays the same. This becomes, the ends cancel out. 2 plus 2 divided by 2 is 1. 2 divided by 3 is 1/3. anything with an n in the denominator, because it's approaching 0, becomes, because it's approaching infinity, becomes 0. 2 plus 1 plus 1/3, 3 1/3. 3 plus 3. All right? Got the hang of it? Let's go for the last one. All right? Whew, whew. All right. Here we go. 1 minus -2 over n equals. What's 1 minus -2? That's 3. 1 plus 2 is 3. -2 plus I 1 over n equals -2 plus 3i over n. All right? Once you get your delta x and your ci, little expansion. 2 times ci squared plus 3. So, FOIL, PEMDAS, parentheses, exponents first. 4 plus 6i over n, 9i squared over n squared. Now, you have to take the 2 and you have to distribute it. You got 8 minus 24 plus 18, okay? Now, look what I have here. 8 plus 3 is 11. My parentheses is done. Now I do my multiplication. To multiply the 3 in, multiply the n in. All right, once again, if you want, you can pull this out front, multiply it in at the end. I like to do it to each one individually though, because a lot of times if I try to do that, sometimes, not a lot, sometimes I forget to put it back in. Once again, your preference. All right, so expand this using our formulas. I didn't put the formulas up this time. All right, so, pull everything out, pull out 1 over n, 72 over n squared, 54 over n cubed. Now we use our formulas. 33n, this times that, this times this. Distribute. That should be pros. Numerators times numerators, denominators times denominators. Reduce, 72. Sorry, 33, 36, 0, 18, 0, 0. All right. So 33 minus 36 plus 18. Once again, zeros because you're approaching infinity. Answer 16. All right. Whew. That seemed pretty good, right? That wasn't too terrible, was it? All right. Ready to do some easy stuff? That's hard stuff. Now, we're going to finish up with some easy stuff. Be able to take a breather. If f is continuous on the non-negative of the closed interval AB, then the area of the region bounded by the graph of f is the blank, is the x-axis. So it's bounded by the graph of f. That's one. Second thing it's bounded by is the x-axis. Then it's bounded by the 2 vertical lines from A and B. All right, it's bounded by, there's the vertical lines, x equals A and x equals B. So what it means is it pretty much boxes off your graph, okay? So you have straight line, straight line, straight line, and then your function's curved. Got it? Now it's given by the function, as we said before, area equals from A to B, f of x dx, which is what we just did. Now what we're going to do is, next lesson will be 5-4, a little bit more difficult. But for this one, we're just going to sketch the region corresponding to the definite integral, and then evaluate it just using geometry. We're going back to geometry. All right, what's the graph of 4 look like? So graph of 4 is a horizontal line at 4, right? You're going from 1 to 3, so those are my 2 vertical lines. So from 1 to 3. Now what kind of figure is this? This is not a circle. It's good. It's a square, not a square. It's a rectangle. So area of a rectangle is length times width. Let's look. So this is our area right here. So length times width, we got 4, 1, 2, 3, 4 boxes high, 2 boxes wide, or the length's 2, the width's 4, interchangeable as I said before. So 4 times 2, and that gives you 8. Right? 2 times 4, 4 times 2, both 8. There you go. Most of the times you can't use stuff like this. So let's do a couple more. Now, what you have to do here I gave you the graph. So let's go. What do you think? Sketch the region for number 13. First thing, graph that, x plus 2. You guys remember how to graph a line? Y-intercept's that 2. Slope is 1, up 1, over 1. So there's your graph. You're going from 0 to 3. What type of shape do we have there? It is a trapezoid. Does anyone remember the formula for a trapezoid? If you were in my geometry class, you definitely remember this because we went over it. It is 1/2 of the height of the trapezoid. The height is the distance between the two parallel sides times the sum of the bases. So here's my trapezoid. We obviously don't know the length of that side, but we do know the height here is 3, and the two bases are 2 and 5. All right, the bases are the parallel sides. So it's half of 3 times 2 plus 5. 2 plus 5 is 7. Half of 21 is 10.5, and that's your answer. See that? All right, this one, obviously, this is a circle. The reason I drew the graph is you guys probably forgot the circle formula. Circle formula is the basic circle with the center at the origin. Remember, is a squared plus b squared is r squared. I think the actual formula is what? A minus h squared plus b minus k, the quantity squared, equals r squared, right? That sound right? So if you solve for actually one of the functions there, it becomes a square root. Anyway, what kind of figure is that? We're going from -2 to 2, so those are my vertical lines, and we're going here. So we want to find the area of that piece. What is that? Not a circle, it's a semicircle. So circle, oh, there it is, a squared plus y squared is r squared. This is how I got this formula. So what I did was I subtracted x squared from both sides, and then I squared it. That's how come that formula came there. Now, how do I find the area of a circle? Area of a circle is, r squared is 4. So your radius here is 2. All right? Oh, so we could have drew the circle ourselves. Whatever. Area of a circle is what? Pi r squared, right? So a semicircle would be, semi is half a circle, half of pi r squared. So it's half of pi times 2 squared, half of pi times 4, which is 2 pi, or 6.26. Right? Now this is only a circle that has an origin, has its center at the origin. All right, which this one does. All right, we good? All right. No, this will not be on your test. All right. List the intervals of the shaded portion of the graphs for 15 to 18. I'm going to finish up this. All right. So, f of x equals 5. So that's a horizontal line. We're going from 0 to 4. All right, because you can see that from this line. 0 to 4, because we're doing the shaded part, right? All right, now, what's its area? Length times width, right? So 4 and 5. 4 times 5 is 20. Pretty easy. All right, 16. What type of shape is this? Triangle. So our start point is 0. Our end point is 2. So we're going from 0 to 2. All right. What formula? Formula triangle is half the base times height. Base here is 2. The height here is 6. Half of 2 times 6 is half of 12, which is 6. Those are easy, weren't they? All right, next one. Why do you guys do these two? Don't worry about the formulas so much, just worry about the pictures. Good? All right, for this one, you're going from -4 to 4. Triangle, half the base times height. The base is 8. The height is 4. So half of 8 times 4, half of 32 is 16. Now this was a little tricky. This is curved, so you have to kind of estimate here. Now we left this purple line in here just to help you out. So once again, we're going from 0 to 2, right? But what does this kind of look like, the shape? Kind of a triangle, right? Triangle is half the base times height. But I wouldn't want to go from 0 because then I'd have all this open space. So I go I wouldn't want to go to 1 because then I'd be missing all this. So I'll go between 0 and 1, which is about 1.5. Because then I have a little I'm missing. Oh, sorry, a little bit I'm missing, and then a little bit extra. So it kind of cancels out. And once again, we're just estimating here. All right, so half of 1.5 times 4. Oops, sorry, this should 1, 2, 3. That should say 4. That's the wrong number. All right, anyway, half of 6, which is 3. And that is estimated 3. All right, once again, that should say 4, not 8. All right. All right, 18. What kind of shape is this kind of? What do you think? So this one, we're just finding the areas now. Kind of a triangle, right? So the width is 8. Now, height's 25. 8 times 25 is, half of 200 is 100. Sorry, this graph should be closer. All right. So it's obviously going to be more than 100 because it didn't fill in the whole area. I guess when I transferred it over, I messed it up a little bit. All right. Or what I could do is this should be 10 times 25, half of 250. This should be 125. All right. I thought I really corrected this one. Oh well. Now this figure, there's nothing really that fits this figure, but you can use two shapes. Can you guess what two shapes would be good? How about a triangle on the top? And what about the bottom? With a width and a height. What's that? And a rectangle on bottom. All right, so here's how it works with this problem. You have two shapes. First one is half of length times width, 2 times 0.75, which gives you 0.75, so that's the area of the triangle, and the area of this is length times width. 2 times 1.25 is 2.5, add them together, and you get a whole estimated width of about 3.25. Your answer is obviously going to be a little bit more because there's some spaces here we didn't fill in, but we're, oops, sorry, I'm not on the screen, but we're just estimating. All right? All right, finish up with these 4 problems. All right. Ready? Problem right there. Horizontal line from 0 to 3. Fill that in. That is indeed a rectangle. So height is 4, width is 3. 3 times 4 is 12. Once again, going from negative a to a. So we're filling in this piece right here. So what's the width? We got 4, that's the length. The width is, what's the distance from a to negative a? It's 2a. A minus negative a is, a plus a is 2a. So it's 4 times 2a, which is 8a. Yes, you can have letters there. So depending on what a is, your area changes. X, start at the origin, up 1 over 1. So that creates a triangle. All right, the triangle base is 4, the height is 4. Half of 4 times 4 is half of 16, which is 8. All right, and then finally 24, x over 2 is the same as 1/2 x. So once again, origin is 0, 1/2 means up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, right? Or you could just say if I type 0 in here, I start at 0. If I type 4, 4 divided by 2, I end up at 4. Once again, it's a triangle, half of base times height. You got 4 and 2. Half of 4 times 2 is half of 8, which is 4. All right? All right. You done with these yet? We all good? Last one, I think. Yep, last one it is. Graph this graph. Y-intercepts at 4. 3x means you do what? You go up 3. You go over 1. Notice these all go up by 2s. Up 3 over 1. All right, so you're going from 0 to 2. What type of figure is that? It's a triangle and a rectangle, or a, you did one of the first ones, trapezoid. Trapezoid, you said, was 1/2 half. 1/2 of height, base 1 plus base 2. Height here is 2. The bases are 4, 0, 2, 4, and 10. So half of 2 times 4 plus 10, which is half of 2 times 14. Half of 28, which is 14. All right. Now, 26. Let me get out of your way. Go to a bad side. All right. So this one right here, 6 is what we start at. Minus x means your slope is -1. Down 1 to the right 1. Down 1 to the right 1. All right. All the way till you get to 6. 6 minus 6 is 0. All right. You're going from 0 to 6, and you're making a triangle, right? Base and height are both 6s. Half of 6 times 6 is half of 36, which is 18. All right. All good? Oh, easy, more easy stuff. All right, so, all right, we're going to finish strong. Definitions of two special definite integrals. So, if f is defined as x equals a, then we define, so this is, we're just switching up the whole lesson here, so you know. All right, so if you're going from a to a, what do you notice about the a's? They're the same. So if you're going from the same point to the same point, what do you think the answer is? You're not moving. So what's the area under something that doesn't move? 0. Really should never happen. It's kind of stupid. So if I was going to find the integral of sine x dx from pi to pi, my answer would be 0. Because the sine function is defined as x equals pi and the upper and lower limits are equal. Anytime your upper and lower limits equal, answer is 0. Second time, and you'll barely ever see these, but say what happens is f is integral on a, b, and we define this as from b to a. Now what is different from this one from the other one? A's and b's are flipped. B is supposed to be the upper limit, right? So your answer is actually just going to be negative. Okay, so if you did that and you flipped it, and you went backwards, which you never really do, it's the same exact answer you had. The answer now is just negative as opposed to positive. So look what this says here, number 28. So the integral from 3 to 0, so from 3 to 0 of this is the same as in example 13. So if you go back to example 13, we did this example from 0 to 3, all right? And that answer was 10.5. Now what do you think the answer for this one's going to be without doing any work? Any guesses? Negative, whatever this answer was, right? So negative 10.5. That's it. Whoops. That's your answer. So if you go backwards, the answer is just negative of the answer you had. Can you have a negative area? Yeah, you would have a negative area if there is more of the shaded part under the x curve than above the x curve, okay? In real life, you can never have a negative area, but when you're dealing with area under a curve, you can have a negative area, all right? So, antiderivative, interval, what's that? Addition, I can't even read yet. Interval property, if f is integrable on 3 closed interval and determined at a, b, and c, then this happens, right? So watch this. From a to b. So, say you have 3 different portions of your graph. One's from a to c, one's from c to b, all right? So, if you have one from a to c, one from c to b, you can add these two and they'd be from a to b. Now, c right here would have to be between a and b, though, okay? So that means if you have 2 portions of a graph, you can add the 2 portions to give you the big portion. You would use this when you're doing absolute value. That is the main and only reason you would really use this. So, using the addition interval property, you remember to do absolute value? In case you don't, you would have to do from -1 to 0 of negative x, and then you'd have to do from 0 to 1 of a positive x. Because absolute value always makes your answer positive. So the reason we make this a negative x here is this answer will be negative, but we have to make a negative times a negative is a positive. So you would solve this, okay? Interval from here to here is 1/2. I'm sorry, the integral from here to here is 1/2. The integral of this is also 1/2, and your answer would be 1. Now, how do I know these are both 1/2s? You will see very shortly, right? All right, f is your integrable on a, b, and k is a constant. Then the functions k times f and f plus or minus g are integral on a, b. So these are just some properties that we'll be using later on in the next couple lessons. Very simple. The same as the derivative properties, now you're just using integration. So what do you think you do with that k? Pull it out front. So it's k times from a to b of f of x dx. What do you think you do here? You just integrate each one individually. So it's the integral from a to b of f of x dx plus or minus the integral of g of x from a to b dx. And what happens if you have three of them? You just do this 3 times. You integrate the first one, plus or minus integral the second one, plus or minus integral the third one. If you have 4 or 5, you just keep on going and going and going. All right? So pretty much you can just integrate each one of these as their own individual problem and then combine everything together in the end. All right? And that's just with functions with multiple things inside of it. Got it? And we did the same thing before, we just didn't have the a's and b's attached. Notice the a's and b's never changed. So what this says is, and this is just a precursor to what we're doing next lesson, probably could have included it, evaluate each of the following values. Now, I know we don't know how to find these yet without using that big expanded form that we've been using, the Riemann sums. So what we're going to do is, I'm just going to give you the answers here, and then eventually I'm going to show you shortcuts on how to find all these. So first one, notice x squared, x, and then a constant, right? I know that the integral from 1 to 3 of x squared is 26 over 3. Someone did experiments and found that out. The integral from 1 to 3 of x is 4, and the integral of the integral of 1, or just regular dx, is 2. All right, so I can use these 3 bits of information to solve this problem. All right, eventually you're going to have to find this all out yourself. So watch what I do. X squared gets replaced with this. X gets replaced with 4. So it's 4 times 4. Oh, wait, what am I doing? Oh, so I'm adding all 3 of these together. All right, so I integrate each one of these individually. X squared gets replaced. I pull out the x squared, I pull out the 4, and I pull out the 3. Now, the reason I do this, I always do this in one step. That's why I keep on messing up. Because this is where you can pull your k out front. All right, now, x squared, this whole thing, equals 23 over 6, 26 over 3, plus 4 times this whole thing is 4, minus, now I normally don't pull out my 3, but I just did it in this case, this equals 2, it's minus 3 times 2, plus 8 minus 6, all right? It's like algebra, you're just plugging in things that you're using a substitution method, all right? Evaluate each using the following values. So why don't you guys try these real quick? All right. Answer 6. No, the answer is not 6. Look it. This is flipped. So you have to make it negative. Ah. So it'd be the negative of whatever this is, and this is 6. So my answer would be negative 6. What about 32? 32, the answer would be A and B to equal. So the answer would be 0. All right. This is a normal one. Pull the 8 out. Let's integral this. 6. 8 times 6 is 48. Now, say this is from 2 to 8. Can you just double it? No. It can only be true if it's from 2 to 4. You can't kind of like average things and make them change like that. All right, so this one's 25. We're going to use this one. We pull the 25 out. Integral of this is 2. 25 times 2 is, whoa, 50. Is that the same one? This is 50. Where'd that 1 come from? All right, why don't you guys try next couple problems and we'll go over them. We good? All right, hopefully you pause and split this up. So you got the integral from 2 to 4 of x dx minus the integral from 2 to 4 of 9 dx. Pull the 9 out front. So this stays the same. 9 comes out front. Replace with the 6. Minus 9 times 2. 6 minus 18 is negative 12. Split it up. X cubed, 4 dx. Pull the 4 forward. 60. 4 times 2. 60 plus 8 is 68. Right? All right. 37, 38. Let's go. We only got 4 more problems. No, 2 more problems. All right, so split this up. pull the half out, pull the 3 out, pull the 2 out. Right? All constants. 60, 6, 2. 30, minus 18, plus 4, 16. Okay. Split up. 10 dx, integral 4x dx, minus 3x cubed. Pull out the 10, pull out the 4, pull out the 3. Replace this with a 2, replace this with a 6, and replace this with a 60. 20 plus 24 minus 180 gives you 136. And there you go. That's evaluating integrals if you know the answers. Now we're eventually going to find out how to find these and move on. The last thing, this is something I just had to throw in because it's in the book. If f is integral on a non-negative closed interval a, b, that means that if it's non-negative, this is always going to be greater than 0. Okay? It's just saying it's non-negative integral and it is a function. Okay? If f and g are integrable on the closed interval a, b, anytime f of x is less than or equal to g of x on that integral, then what this says is the two integrals will equal each other. Okay? That's it. All right, we don't need to really go into that stuff. That was just ending it up. So we finished up Riemann sums and definite integrals. Hopefully you guys learned how to understand the definitions of the Riemann sum. That was the summation stuff. Evaluate definite integrals using the integrals. That was the integral with the a and the b, and as n is approaching infinity, pretty much using Riemann sum. And then we just did a little bit of area and definite integrals in the end. All right, so until next time, this is going to complete these sets of lessons. We'll do a review on 5.2 and 5.3 next time, and then we'll test time. All right, and then we'll finish up the year with 5.4 and 5.5. All right, so have a good day, and hope you learned something.